Hi friends, welcome to the course Mathematics using Python. So in today's lecture, I am going to teach you how to find the inverse and the determinant of a matrix using Python. We know how to find the determinant of a matrix and how to find the determinant of a determinant and inverse of a matrix numerically. We know how difficult it is to find the determinant and the inverse also. Okay, so I am going to teach you how we are going to find the inverse and the determinant using Python. So for that, it is very similar in the previous class. So I'm starting with the determinant. Okay, determinant, and I'm going to import the numpy. So import numpy as np. So once you declare that in the initial stage itself, it is import npy as numpy as np. You need not to declare in all the sessions, but it is a new lecture video, so that I am including this. Okay. So I'm declaring my capital A. My capital A is equal to np dot array, and I'm going to find the determinant for a 3 by 3 matrix. So I am putting 3 open braces and 1 square bracket with the value like minus 2, sorry, it is 2 actually, 2 comma minus 1 comma 1, and for the next row I am putting a separated comma, square bracket, then minus 1 comma 2 comma 1. So then for the next element, separated comma, square bracket, it is 1 comma minus 1 comma 2. So I want to check whether what is my A. So it is print A. Okay. Yeah, this is RA. So now I want to find the determinant of a matrix. So determinant of a matrix is nothing but determinant underscore capital A. For this, I am using the function linear algebra. So np dot linear LIN linear algebra, okay, dot determinant of a matrix capital A, right? So I want to find the determinant. So just I'm printing this determinant A, print determinant of capital A. Yeah. So we are printing capital A. The capital A is 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2, and the determinant is very easy, and that is 4. So to find the determinant we are going to use this np.lin algebra dot determinant A. Okay. So we'll move to the next problem. So suppose my capital B equal to np dot array. I am going to consider a 2 by 2 matrix. Okay. So open brace, 2 open braces, because 2 by 2 matrix. The first element is 1 and 2, comma. The second element is 3 and 4. Okay. So I want to find the determinant of this matrix. So determinant underscore capital B, that is equal to np dot lin ALG, that means linear algebra of determinant, okay, of a matrix capital B, right? Yeah. So we can run the program, but we didn't get anything because we didn't ask them to print the output. So print determinant of capital B. Before that, we have to check what is B. So print, yeah, capital B, right? Yeah, you could see the matrix of 3 by 3 matrix, and you can find the determinant of the matrix. Yes, friends. Next, we are going to find the inverse of the matrix. Okay. So we know that to find the inverse of a matrix, we must know the determinant of a matrix, right? So to find the inverse of matrix. Okay, so I'm going to do the same process again because I want to check the determinant, and then if it is not equal to 0, then I could proceed with the inverse, right? So I'm using the same function, and I'm adding only one additional thing, that is the inverse part. So inverse of capital A is nothing but, again we are using the same linear algebra function. Okay, so in np dot lin alg dot inb, this np is the numpy library, linalg is nothing but the linear algebraic function, and inverse is the function which we are going to find, inverse of capital A, and we want to print that. So print inverse of capital A, right? Similarly, we are going to do for capital B also. So I am simply copying Control C and put enter, Control V, and you can replace your A with B so that you can find the determinant, sorry, inverse of capital B. Okay. So we know that once the determinant is not equal to 0, so that we could find the inverse. Yes, well done. Now we are having the matrix, and it's determinant 4, and we are having the second matrix and it is determinant -2, and this is the inverse of the matrix, first matrix. Okay, minus 0.75, 0.25, minus 0.25, etc. And for this is for the second matrix inverse. We know how difficult it is while we do numerically, but it is so simple while you do using Python. Okay, so we in this lecture we learn how to find the determinant and how to find the inverse of a matrices, right? So I'll meet you in the next video lecture with differentiation. So we are completely learn all the concepts of matrices: addition, multiplication, scalar multiplication, subtraction, and inverse, determinant, everything. So in the next video lecture we are going to see what is limit, and what is differentiation, how this limit coming from differentiation, and how we finding the limits and differentiation of a function using Python. Thank you. Meet you in the next video lecture.